There are two metrics for measuring angles, radians and degrees. Let's first look at the definition of an angle. An angle has two sides, an initial side and a terminal side, and they meet at a point called the vertex. Many of the angles that we'll look at are in the standard position. This means that the initial side of the angle lies on the x-axis, and the terminal side lies elsewhere. There are two ways to measure an angle, either a positive angle or a negative angle. A positive angle starts at the x-axis and goes counterclockwise until we reach the terminal side. A negative angle also starts at the x-axis and goes clockwise till it reaches the terminal side. So remember, a positive angle goes counterclockwise from the x-axis. A negative angle goes clockwise from the x-axis. Two angles are coterminal if they have the same initial and terminal side. Let's look at a couple of examples. In example 1, we have angle A, which is a positive angle and counterclockwise. And we have angle B, which is a negative angle and clockwise. But notice that they both end up at the same location or the same terminal side. These are coterminal angles. Let's look at another example. In example 2, we have angle A, which is a positive angle and is counterclockwise. But we also have angle B, which is also a positive angle and goes counterclockwise. But it makes a full revolution, and then it keeps going past the x-axis until it reaches the terminal side. Both of these angles are identical, and therefore they are coterminal angles. So you might be familiar with degrees. Remember from geometry that there are 360 degrees in a circle. On the x-axis, we have 0 degrees and 180 degrees, which forms a straight line. On the y-axis, we have 90 degrees and 270 degrees. You can see the other angles in between. These are common angles that we'll be working with every day, throughout trigonometry and in future lessons. Radians might be best to be looked at a first glance using an animation. So I'm going to go ahead and play a video, and we're going to take a look at that, and we'll come back to the radians in a circle. So a circle is being drawn with a radius, r. Then the radius is extended vertically and then wrapped around the circumference of the circle. The length of one radius is 1 radian. That radius can be extended around the circle to form 2 radians, 3 radians, 3.14 or pi radians. Notice that that's exactly half of the circle, or 180 degrees. And all the way around the circle is 1 revolution, or 2 pi radians. Or in decimal terms, because pi equals 3.14, 2 times 3.14 is 6.28 radians. So let's take a look at our diagram again after looking at that animation. So in the video, we had a radius here, and then it was wrapped around the circumference of the circle. If we wrapped it around the circumference of the circle one time, we got 1 radian. If we wrapped the radius around the circle again and extended it around the circle, we got 2 radians. A third time, 3 radians. Now notice that we're almost 180 degrees around the circle. If we go just a little bit more, we'll be at pi radians. In other words, pi, or 3.14 radians. That's an important concept and relationship to understand, that pi equals 180 degrees. If we continue around the circle to 4 radians, 5 radians, 6 radians, we need just a little bit more to make 1 full revolution around the circle. And that amount is approximately 0.28. The reason it's 0.28 is because once we got around the circle again, if halfway around the circle was pi, all the way around the circle would be 2 pi. Because pi equals 3.14, 2 times 3.14 equals 6.28 radians. So remember, half of a circle is pi, a whole circle is 2 pi. In decimal terms, half of a circle is 3.14, a full circle is 6.28 radians.